So we've done distance, we've done fractional distance. Today our notes is titled, so today is Midpoint Formula. I want you to brainstorm everything that comes to your mind when you hear midpoint. Everything that comes to your mind, and do a brain dump in the chat. Anything that makes you think of midpoint, type it in the chat. Middle. Lines don't have middles. Point in the middle. Lines don't have middles. Stop saying that. Center. In between. Mid-coast. Center, point in the middle. Bisect, that's a good one. A bisector that's a point, good. So the official definition that you had on your vocab sheet at the beginning of the year was a point that divides a segment into two congruent segments. So write that down in your notes. A midpoint is a point that divides a segment into two congruent segments. Some people might say halfway, split in half, equal parts. Those are some other words we could have used. Let's sketch a quick picture of a midpoint. So let me draw segment. I'm purposely drawing it diagonal because it's my pet peeve when we draw everything perfectly horizontal and you get to your homework and all the segments have weird slopes and stuff. So if this is segment AB, and I wanted to indicate that M is the midpoint of AB, I can't assume it's the midpoint. I can't assume that it's in the middle, but if I put tick marks on either side like that, if I add a marking, now M has been promoted. M, you're not just a point anymore, you're the midpoint of segment AB. So put tick marks around your midpoint so that you can communicate mathematically that it's right smack in the middle. Let's try an example finding a midpoint on a number line. So given point A at coordinate -2, and point B at coordinate 4, find the midpoint of AB. So obviously we started with a very easy problem, one that you probably could just eyeball the midpoint, but I wanted to start with this problem so that we could talk about all the different methods we could use to find a midpoint. All right, so type your answers in the chat. The midpoint is at coordinate 1. Let's talk about 3 different ways we could have arrived at that answer. There might be more than 3 ways. We could approach this like we approached it yesterday. We could find the distance from A to B, -2 to 4. We could find the distance, which is 6. We could divide that by 2, because that's how you find the middle, half it, and that would equal 3. And then we could go to our end point and travel 1, 2, 3. That's one way to do it. That's kind of how we learned how to do fractional distance yesterday. But fractional distance, when it's 2/7, is harder than finding a midpoint that's 1/2. So give me another way. Audie said he found the mean. Y'all remember what mean is? Another word for mean is average. He found the average. So you take the end points, -2 and 4, you add them up, and you divide it by 2. Do you ever average out your grades? You made a 90 on the first test, you made a 98 on the second test. What's your test average? Well, you add them up and divide by 2. That's how you find the middle. That's how you find an average. So good. -2 plus 4 is 2. 2 divided by 2, whoa. If we do it that way, we already have the answer, and there's no other steps. The only thing about up here is find the distance, divide by 2, then add it back onto the end. That's 3 steps. If you do the midpoint formula, you have calculated the answer without multi-steps. The only other way that I had in mind was if you had this number line in front of you and it was perfectly drawn to scale, you could use a ruler and find the middle, right? A ruler, I'm thinking of way more than 3. You could take that paper and fold it. When you fold it, where would you want A to land? You'd want it to land right on top of B. So if you folded that where A was right on top of B and creased it, then you would have found the middle. So that's another way to find the middle of a segment. Fold the segment in half. Yep. Alrighty, try this example. Write it in your notes. So now that we have this example, some of the things we talked about on the last page, they go out the window. Measuring this with a ruler, if it's like over 100 units long, that's really not feasible. Folding it, if this was drawn to scale and it was too big, we wouldn't be able to fold it. On this last one, if some of you like put your fingers at A, B, and you just kind of went 1, 2, 3, and you moved your fingers on the way to going to M, that's not feasible on this. You can't put your finger on 92 and negative 16 and start counting inward until you meet up. You'd be here forever. So really, our most efficient way that will work on any problem would be the formula we came up with. It's not really a formula. You find the average of the endpoints. You add them up and divide by 2. You find the average, the mean. Okay? So if I do 92 plus negative 16 and I protect it with parentheses, oh so important, and divide by 2, we get the middle as 38, right? Yes, that's an important thing that someone brought up. If a segment has a midpoint, well, not if, a segment will have one and only one midpoint. And when we find midpoints, it's always between 2 points, not between more than 2 points. If you got a different number, then you maybe did not put parentheses around this when you put it into your calculator. So you need to make sure that you do 92 plus negative 16, close parentheses, divided by 2 in your calculator. Now, how could we check our answer? Like if you got something that wasn't 38, how could you check your answer? How could you verify that M is the midpoint? No, Meringue, no. How could you verify? If M is the midpoint, what does that mean? That means it's in the middle. Yeah, what does that mean about the distance from E to M and the distance from, F to M? There we go. That means those should be the same. They should be equal. So let's do it. Let's find the distance. So how long is segment EM? 38 minus negative 16. 54. FM, 92 minus 38. 54. We got 54 both times, so we verified that M is a midpoint. All right. So we're done with number line, one-dimensional midpoint. Now let's do coordinate plane midpoint. And it's not much different than our number line midpoint. So if we treated this like fractional distance, like we learned yesterday, what would we do here? We would find the rise, we would find the run, 2, and 6. Then, what would our fraction be if we're doing midpoint and it's fractional distance? What's our fraction today? Good, it's 1/2 all day long. So if we multiply it times 1/2, we get 1, and we get 3. So instead of rising 2 and running 6, we're going to rise 1 and run 3. We have a new rise and a new run. We're going half of the rise and half of the run. And so our answer is 1, 2, 3, 4, 5, 6. What's another way we could get this that's shorter than doing it the fractional distance way? How could we come up with 6/4 without doing the rise and the run fractional distance way? Fold it. Yes, we could fold it. What else? Audie, our answers might not always be whole numbers, so don't approach it that way. We're not going to calculate the distance. So we're going to do just what we did on the number line. On the number line, we found the average of the endpoints. We're going to do that here. Good, Pranika, except we're going to do it separately. We're going to do it with our x's, and then we're going to do it with our y's. So we're going to do the same thing we did last time. Add the x's and divide by 2. And then we're going to do it to the y's. Add the y values and divide by 2. 3 plus 9 divided by 2. 6. 3 plus 5, 8 divided by 2. 4. And that is the midpoint formula. Write it down in your notes. So you find the average of the x's, the average of the y's. The average of the x's, the average of the y's. Add the x's and divide by 2. Add the y's and divide by 2. So when you find the distance between 2 points, you're always subtracting. Every time to find the distance, you subtract. To find the midpoint, to find the middle, you're adding and dividing by 2. People get confused about which operation to use. Let's try out our new formula. It's like breaking in a new pair of shoes. Let's break in this formula. Yeah, the order doesn't matter because think 1 plus 2 is the same as 2 plus 1. Is that the commutative property or associative? It's a property, and it says that it doesn't matter which one you put first when you're adding. I should know that. The time. So we can organize it like we did with the distance formula if you want. Circle your x's and underline your y's. The formula says add your x's and divide by 2. Add your y's and divide by 2. That is the midpoint formula. I am not putting parentheses in the numerator, but please know you must protect the numerator with parentheses if you want to just put it all in the calculator. If you want to do it in your head, then you don't really need the parentheses. You're going to do that order of operations by yourself. -1 plus 7 is 6. 6 divided by 2 is 3. 3 plus -7 is -4. -4 divided by 2, -2. And there's the midpoint, 3, -2. So the last thing that we're going to talk about today is finding not a midpoint, but finding an end point. Finding, let's say I know, we ran out of time to do this example, but if I know that B is the midpoint of AC, where is A? You know? So if I travel here, where is A going to land? What will the coordinates of the other end point be? We know B has to be equidistant between A and C, but how do we find the coordinates of A? All right, let's try it. So in your notes, go ahead and write these coordinates just like I have them. Write 2, 9, and then next to it write 7, 3. And then write empty, empty. So you're going to circle your X's and underline your Y's. That's a common theme. We do that almost every time. So, did you ever play leapfrog when you were growing up? How someone kneels down and someone leaps over them and then they kneel down and then you leap over the next person? I don't know. I think my frog rivets, actually. Let's see. I don't know if y'all heard it, but he's riveting. Okay, anyways. So, we're going to play leapfrog. We're going to leap from leap pad to leap pad, from X to X to X. When I leap from 2 to 7, how far do I leap? Plus 5. 7 minus 2 is 5. So I'm going to leap plus 5 again because I want that midpoint to be equidistant between the endpoints. 7 plus 5, I land on leap pad 12. This is better than midpoint formula, right? This is more fun. Okay, now I do my Y's. I leap from 9 to 3. Ooh, I went backwards. That's negative. Okay, from 9 to 3. I went backwards 6, so I'm going to leap backwards 6 again. 3 minus 6, and we have our end point. So to find midpoint, you use a formula. To find end point, you can use leapfrog. It'll work every time. Let's try one more and then we're done. If B is the midpoint of AC, find the coordinates of C. So we need to set this up in the right order. We need to put endpoint, midpoint, endpoint. We need to be very careful about that. So don't line them up like I gave them to you. See how I gave them to you in the wrong order? I need to put an endpoint first. It doesn't matter which endpoint goes first. Either one. Either one. Then I put my, is B the midpoint? Yep. Then I put my midpoint. Then I can put my missing one. Endpoint, midpoint, endpoint. Okay. Circle your X's. Let's leap. Ready? 0 to -3. -3. You're at -3. You go backwards 3 more. -6. 15 to 7. Leap. How do you get from 15 to 7? Good. Nope. Try again. Good. -8. So we're going to leap -8 again. 7, leap -8. You land at -1. So what are the coordinates of C? The coordinates of C are -6, -1. That is the answer. Let's summarize what we learned real quick because we did a lot today. So we learned how to find midpoint on a number line. If this is A and this is B and you want to find M, you add the endpoints and divide by 2. We learned how to find midpoint on the coordinate plane. You add your X's and divide by 2. You add your Y's and divide by 2. That's the midpoint formula. And then we learned how to find endpoint. And to find endpoint, you leapfrog with your X's and you leapfrog with your Y's. So those are the 3 main things we covered today. Make sure you try your homework tonight.